Here I have a problem. It says strategically located substations are extremely important in the transmission and distribution of a power company's electric supply. Suppose 3 substations are located at the points 3, 6, -1, 2, and 3, -4. I want to determine the location of a town equidistant from all 3 substations and write an equation from the circle. In other words, I want to find the center of my circle. So we're going to combine what we did here with what we did the other day, or the other lesson, I should say. So D is at 3 and 6. I'm off the grid for D. E is at -1 and 2. And F is at 3 and -4. So what happens here, these are my chords. And what I'm going to do, I know the diameter is the perpendicular bisector of a chord. So I'm going to bisect 2 of my chords and see where they intersect at. Now I do like point DF because I notice that's a vertical line, isn't it? So what happens is I'm going to find the midpoint of DF. So that's going to be 3. If I go 6 plus the -4 is 2. So 2 over 2, right? Or 3 and 1. So I'm going to go over 3 and I'm going to go up 1. And I'm going to draw in my diameter. Now, I don't know where that diameter goes through, but I do know it's a nice horizontal line. And I'm going to fix that just a tad bit here because it's not quite where I want it to be. There we go. So I know the equation of my diameter is y equals 3. Now I'm going to have to do a little bit more work for my other points. So let's find the midpoint. Well, let's go, it doesn't matter. Let's go DF. I already did DF. Let's go DE. So I want to find the midpoint of DE. So I'm going to say -1 plus 3 over 2 and 6 plus 2 over 2. So -1 plus 3 is 2 over 2. 6 plus 2 is 8 over 2. So my midpoint is going to be at 1 and 4. So if I go over 1 and up 4, and I didn't quite draw that correctly, my point is off a little bit there. Now I want to find the equation of the perpendicular bisector of this line. So I have to go back, and I got to find the slope of DE. So if I find the slope of DDE, I'm going to subtract my y. So I'm going to say 6 minus 2 over, we'll go 3 minus a -1. Well, 6 minus 2 is 4. 3 plus 1 is 4. So I know my slope is 1. Well, I know the perpendicular slope is the opposite reciprocal of 1, so my slope is -1. So let's write the equation of my line. I'm going to pick one of my points. I'm going to pick my midpoint, which is 1 and 4. I'll write this in point slope form because I know the point, which is 1, 4, and I know the line that's perpendicular to it. So then I'm going to say y minus 4 equals -1 times x minus 1. And maybe I'll just graph that so I can see this now, because I know I'm at 1 and 4. I'm going to go back and make that a little bit easier to see. So I go up over 1 and up 4. And I know my slope is -1. So if I go down 1 and to the right 1, and notice my 2 points, the center of my circle is where these two lines intersect, which is going to be over 4 and up 1. Okay, so now I got my center of my circle. I'm going to change pen colors here so you can see that. Now I have to find the radius. We got a lot of work to do on this problem, don't we? So I'm going to pick between 2 points. I'm going to find the distance from 4, 1 to 3, 6. I'm going to go from my center to point D. So I'm going to use those 2 points. So to find the distance, remember, I'm going to put down and 3 and 6. So distance equals, and I'll go 3 minus 4, the quantity squared, plus 6 minus 1, the quantity squared. Well, 3 minus 4, the quantity squared is -1. And 6 minus 1, the quantity squared is 5. So then I get 1 plus 25. So D is the square root of 26. So D squared is 26, which is actually my R then. So R squared is 26. So now I know R squared, and I know my center. So now I can write the equation of my line. So I'm going to say y minus 1, the quantity squared. Let's go x first, because that's usually how we see it written. So I'm going to go x minus 4, the quantity squared, plus y minus 1, the quantity squared. That equals to 26. Now what I want to do is let's check this. If you're a better drawer than I am, you could actually graph this on your circle. So but kind of hard to graph the square root of 26. So I'm going to use technology here. So I'm going to go into Desmos. And I'm going to plot my 3 points. Well, my 3 points, D is at 3, 6. So I'm going to go 3, 6. Whoops, I put a decimal there. I meant a comma. 3, 6. I'm going to label that. I'm going to call that point D. My second point is going to be at -1 and 2. So -1, -1 and 2. I'll label that. And that's going to be point E, right? -1, 2, I forget. Let's go back here. Point E is -1, 2. So I'll label that as point E. Point F is 3, -4. And I'll label that as point F. So now I got my 3 points. Now let's write the equation of our circle. So the equation of our circle is x minus 4, the quantity squared, plus y minus 1, the quantity squared, equals 26. So I'm going to go x minus 4 squared plus y minus 1 squared equals 26. And look at that. My circle goes through all 3 points. D, E, and F. So to find the center, if you're given points, what you do is you find the perpendicular bisector of two of your chords. And where those two chords intersect, that's the center of your circle.